Welcome back, everybody, for another deep dive. This time we're going to be looking at Google's Willow chip.
Oh, very cool.
And, quantum computing, as our listeners do, is something that has a ton of potential to completely revolutionize so many different fields, especially things like medicine, energy, AI.
Absolutely.
And so what we want to unpack today is what exactly is this Willow chip?
Okay.
What's the technology behind it?
Yeah.
Who can actually use it? And does it spell trouble for existing chip giants like Intel, AMD, NVIDIA?
All right. I like it.
All right, so to help us navigate this incredibly complex and fascinating world, we have with us an expert in quantum computing. Welcome to the show.
Thank you. Thanks for having me. Yeah, it's a very interesting time to be talking about quantum computing, and Willow is a very significant development.
Yeah, so let's just start with the basics. Willow, is it just another chip, but with a quantum twist, or what are we talking about here?
It is a chip,
okay,
but it's a quantum processor, the heart of a quantum computer. And what sets Willow apart is how it tackles a major hurdle in quantum computing. Errors.
Errors?
Yes.
But computers are supposed to be like the epitome of accuracy. Where do these quantum errors come from?
Right, so it all boils down to qubits. These are the building blocks of quantum computers. Now, unlike the bits in our classical computers, which are either a 0 or a 1, qubits leverage this principle called superposition, where they can be both 0 and 1 at the same time.
Right.
Which means they're incredibly delicate, and even the slightest interference from the environment can cause errors.
So how do they address that? I mean, they can't exactly wrap each qubit in bubble wrap, can they?
No, they can't.
Yeah.
So this is where Willow's design really shines. It uses a technique called quantum error correction.
Okay.
And what's remarkable is the more qubits Willow uses, the fewer errors occur.
So it's getting more reliable as it gets bigger.
Exactly.
That seems completely counterintuitive to how we normally think about, technology.
It is. This is a huge breakthrough below threshold error correction. They've actually shown beyond break-even, meaning arrays of qubits last longer than individual ones, proving the error correction is working. That's a big step.
Yeah, so all this sounds impressive in theory. But has Willow actually been put to the test?
It has, yeah.
And if so, what happened?
Well, the results are pretty astounding. They ran Willow through something called random circuit sampling, RCS. It's a benchmark problem designed to be really hard for classical computers, but much easier for quantum computers.
Okay, so RCS is like a quantum obstacle course.
Yeah, you could say that.
Okay.
Willow completed this RCS task in under 5 minutes, while a top supercomputer would take an estimated 10 septillion years to do the same thing.
10 septillion.
Yeah.
I don't even know how to wrap my head around that number.
Yeah.
What does that even, can you even help us grasp what that difference means?
Well, think about it this way. 10 septillion years is longer than the estimated age of the universe.
Right.
So it really highlights that this isn't just a speed improvement.
Right.
This is a fundamentally different kind of computing. Some physicists even believe this points to quantum computers potentially tapping into parallel universes to do these computations.
Okay.
So it's pretty mind-blowing.
Yeah, parallel universes. We're getting a little sci-fi here, but
A little bit.
before we get too lost in the multiverse here,
Yeah.
I do want to just kind of dial back in on the specifics of Willow a little bit.
Sure.
We know it's got 105 qubits. Are we going to see kind of like a race to just pack more and more and more qubits onto these chips?
It's not that straightforward. While having many qubits is important, Google seems to be focusing on the quality of those qubits.
Okay.
It's not just about quantity, it's about ensuring each qubit is top-notch and contributes to reducing those errors. They're aiming for reliability and precision.
So it's more about building a really solid foundation than just, making a bigger structure.
Exactly. And it seems to be paying off based on Willow's performance.
All right, so this all sounds very exclusive. Who actually gets to use Willow? I mean, is this available or is it locked away in some Google lab somewhere?
Right now, access is likely limited to researchers and developers working on cutting-edge quantum applications. We're still in the very early stages, so it's not like you can just order a Willow chip online.
Right. But Google does have its quantum AI lab, right?
Yes, they do.
And so what are they doing with Willow?
They're focused on developing real-world applications for this technology. While access to Willow itself might be restricted, the knowledge and advancements from Google's research will definitely have a big impact.
Okay, so the big question now is, should the major chip makers, should they be worried? Is Willow a threat to companies like Intel, AMD, and NVIDIA?
It's a bit early to say for sure. Willow isn't designed to replace the chips we have in our laptops or phones. Quantum computing is tackling a different set of problems, problems that classical computers just aren't efficient at handling.
But there's a deal coming, Ray.
But in the long run, quantum computing has the potential to disrupt industries that depend heavily on computation. Fields like drug discovery, materials, science, finance, these could be revolutionized.
So while the big chip makers might not be panicking, yet they're definitely keeping a close eye on what's happening in the quantum world.
Oh, absolutely. And who knows, maybe in the future we'll even see hybrid systems combining classical and quantum chips. The future of computing is very interesting.
Yeah, and this is really just the beginning of our deep dive into the world of Willow and quantum computing.
So we've been talking about the potential impact, and I think it's worth exploring how Willow specifically could reshape various industries.
Yeah, you mentioned drug discovery, material science, finance. Let's start with drug discovery. How could a quantum computer, like the one running on Willow, actually change the game when it comes to developing new drugs?
Well, imagine being able to simulate the interactions of molecules at the atomic level with incredible precision.
Right.
That would be a game changer for drug development.
So instead of spending years and millions or billions of dollars on lab testing and trial and error, we could actually design drugs on a computer with pinpoint accuracy.
Precisely. Quantum computers could provide a level of understanding about how drugs work at a fundamental level that is just not possible with classical computers. This could really accelerate the development of new treatments for diseases like cancer, Alzheimer's, and countless others.
Wow, that's incredible. What about material science? What kind of breakthroughs could we see there?
Designing new materials, particularly for things like batteries, is a very complex process.
Yeah?
You're trying to optimize the flow of electrons at the atomic level. Classical computers really struggle with this type of simulation, but quantum computers excel at it.
So are we talking about batteries that last longer, are more efficient, power everything from electric cars to our smartphones, thanks to Willow and its quantum counterparts?
It's definitely a possibility. And it's not just batteries. Quantum computers could help us design entirely new materials with properties we can only dream of right now.
Speaking of energy, you mentioned fusion energy research earlier. Could Willow play a role in helping us unlock that holy grail of, clean energy?
Fusion energy is a monumental challenge. It involves controlling incredibly hot, dense plasma. And the complexities involved are immense. Quantum computers, with their ability to model and understand these really complex behaviors, could be the key to breakthroughs in fusion energy technology.
That would be revolutionary. I mean, it seems like almost every field could be impacted by this technology. What about artificial intelligence? There's been a lot of buzz about the potential synergy between quantum computing and AI.
Yeah, AI relies heavily on complex algorithms and vast amounts of data. Quantum computers have the potential to supercharge those algorithms, allowing them to process information and learn at speeds that are just unimaginable with today's technology.
So we could see AI that is not just faster, but actually smarter and capable of tackling problems that are currently beyond our reach.
It's certainly a possibility. And remember, these are just a few examples. We're only just beginning to explore the vast potential of quantum computing. Who knows what other breakthroughs await us as we delve deeper into this uncharted territory.
It's both exciting and a little daunting to be on the cusp of such a monumental shift in computing. It feels like we're at the very beginning of a technological revolution.
It does feel that way. But as with any powerful new technology, it's important to consider the potential risks and ethical implications along with the benefits.
What kind of risks are we talking about? I mean, could something like Willow be used for harmful purposes?
For example, as quantum computers become more powerful, they could potentially be used to break the encryption methods we rely on to secure our data. This could have serious implications for cybersecurity and privacy.
That's a sobering thought. But surely researchers are aware of this and working on solutions, right?
Absolutely. Researchers are already developing new quantum-resistant encryption methods. It's a bit of a cat-and-mouse game, but hopefully the good guys can stay ahead of the curve.
Let's hope so. What about access to this technology? Will quantum computing be available to everyone, or will it be concentrated in the hands of a few powerful corporations or governments?
That's a crucial question. We need to ensure that the benefits of quantum computing are shared widely and don't exacerbate existing inequalities. Open discussions about the societal impact of this technology are essential to ensure responsible development and use.
It seems we're not just entering a new era of computing, but also a new era of ethical challenges and opportunities. It's a lot to consider.
It is, but one thing is certain. The future of computing is going to be a fascinating journey. We're just taking the first steps, and there's so much more to explore.
We've covered a lot of ground in our deep dive today, looking into Google's Willow chip, everything from this, groundbreaking error correction to, the potential to just completely revolutionize everything from medicine to AI. It's clear that, Willow represents like a massive leap forward in quantum computing. But before we wrap up, I want to go back to something you mentioned earlier about quantum computers maybe tapping into parallel universes.
Right.
And that sounds like straight out of science fiction.
Yeah, it's a mind-boggling concept, but it's rooted in quantum mechanics, particularly this idea of superposition.
Right.
Remember how we talked about qubits being able to exist in multiple states at once?
Right.
The many worlds interpretation of quantum mechanics suggests that every time a quantum measurement is made, the universe branches into multiple versions.
Oh, wow.
Each representing a different outcome.
So every possibility actually happens just in a different branch of reality.
That's the idea, yeah. And some physicists believe that quantum computers operating on these principles of superposition and entanglement might be able to access information from these other branches of reality, giving them a computational edge over classical computers, which are confined to our single universe.
It's pretty mind-bending stuff.
It is.
So just to kind of sum up what we've learned today, Willow is this game-changing quantum processor that tackles the issue of errors in this completely new way. It can do these calculations in minutes that would take classical supercomputers, billions of years.
Yeah.
And it has the potential to transform these fields like medicine, energy, AI, in ways we're only beginning to even imagine.
Exactly. While it's still early days, the progress is really remarkable, and it's a testament to all the brilliant minds working in the field.
Yeah, and it leaves us with a lot of really exciting questions, too. I mean, if quantum computers can outperform classical computers by, this crazy margin, what other seemingly impossible problems might they be able to solve? What incredible discoveries and innovations await us in this uncharted territory? It really does feel like we're at the dawn of a new era of computing.
It does feel that way. The possibilities are truly vast. And while the future is still unfolding, one thing is certain, it's going to be a remarkable journey.
Well said. And on that note, we've reached the end of our deep dive into Willow and the world of quantum computing. Hopefully, this has given you a little bit of a glimpse into this technology that could really change the world as we know it.
Absolutely. This is just the beginning. Who knows what we'll see in the years to come.
So keep exploring, keep asking questions, and stay curious about this crazy world of technology.
Yeah.
We'll see you next time.